Okay, let's start our presentation. Good afternoon to our teachers and friends. First of all, let me introduce myself. My name is Brenda Lim and my group member LING and XIAN. Today, we are going to talk about an investigation about the art of science. Title will be the homopolar motor. Firstly, the objective is to develop scientific knowledge and skill in build the homopolar motor creatively. Secondly, the objective is to introduce and demonstrate the physics concept used to build the homopolar motor. Thirdly, the objective is to investigate the factor affecting the homopolar motor efficiency. Fourthly, the objective is to explain the homopolar motor works in theory. Lastly, the objective is to relate the application of homopolar motor in daily life.
Introduction. A homopolar motor is one of the simplest motors built due to the fact that it uses direct current to power the motor in one direction. The magnetic field pushes upward the battery and the current that flows from the battery travels perpendicularly from the magnetic field. This causes the creation of a force perpendicular to both the magnetic field and current. This force extended on the copper wire, causing it to spin.
Diagram on the right shows the material that needed to carry out the experiment, which is AA battery, copper wire, scissor, neodymium magnet, and highlighter pen.
Procedure. First, wrap the copper wire around the highlighter a few times. Second, bend the wire so that one end touches the positive battery terminal and the other touches the magnet under the negative battery terminal. Then, place the neodymium magnet on the negative side of the battery. Lastly, set the copper wire shape on the battery and wait for it to start spinning.
The induces current increase when the current increase. When the current increases, the strength of the magnetic field of every turn of wire increases, thus increasing the strength of the resultant magnetic field. Besides, the induces current increase when the number of turns of wire increases. When a current flows in a solenoid, each turn of wire produces its own magnetic field. As the number of turns is increased, the magnetic field produced by each turn overlaps to produce a resultant field which is much stronger. Besides, the induces current increase when the strength of magnetic field increases. The higher the maximum energy product value, the greater the magnetic field the magnet will generate in a particular application. Thus, the speed of rotation will increase.
Faraday's law. Faraday's law is a basic law of electromagnetism predicting how a magnetic field will interact with an electric circuit to produce an electromotive force EMF. Faraday's law states that the magnitude of induced EMF is directly proportional to the rate of cutting of magnetic field. The faster the magnetic field changes, the greater will be the EMF in the circuit. The direction of the induced current changes when there is a change in the direction of the relative motion between the conductor and the magnet. The direction of the induced current can be determined by using Fleming's right-hand rule. The thumb shows the motion of wire, the first finger shows the direction of magnetic field, and second finger shows the direction of induced current.
The application of homopolar motor. Homopolar motors have been used in high-torque wind turbines. The mechanics of the motor provide a low-cost means of converting wind into electricity because of the reduced need for multi-directional gears. This motor also requires less maintenance than bipolar motor. Besides, small energies such as those in toy cars can be built using homopolar motor. The spinning wheels create force, which cause the magnet to spin and create a magnetic field. This electricity flow in one direction is used to power the engine. Besides, the homopolar motor is also used in a generator that are installed in electroplating process plant. The generator uses direct current and low voltage, but the current in the motor is high enough to operate the heavy machinery.